coloring sheets. You'll find loads of information on there and on our YouTube channel as well, and also on our social media. So feel free to go and explore those. There's loads of availability on there. But for now, welcome to Ivy Baremore. She is a shark scientist with MarAlliance, and she's currently living in Honduras, where she is studying deep sea sharks and rays, I believe, but she's going to introduce herself in a little bit more detail right now. So welcome, Ivy. Thank you so much for being here.
Hi, thanks for having me. So hello, everyone. As she mentioned, my name is Ivy, and I am currently in Roatan, Honduras. I work for a non-governmental organization called MarAlliance. And I do research on sharks, deep sea sharks, as among the things that I do research on, and that's what I'll be presenting about today. So I'll go ahead. Should I start?
Yeah.
Sharing? Okay. And we'll get that bigger. Okay. So the title of my presentation is Deep Sea Sharks in Belize and Honduras. And to start, I just wanted to actually define what is the deep sea. What is it that we mean when we say deep sea? The general consensus is that the deep sea starts at about 200 meters, which is about 650 feet, a little more than that. And around 200 meters, we have less light level. So the light gets very dim starting around 200 meters, and it gets darker and darker as you go down. The water also gets colder as you go deeper, and there's less and less oxygen available to the animals that live there. Sharks and fish and just about everything in the ocean, they actually consume oxygen just like we do. They use their gills and other structures to absorb the oxygen and to breathe the oxygen. And so because the light levels are low, they don't have things like seagrass that produces oxygen, and you have a lot of things that are consuming the oxygen, so the levels become less and less the deeper you go. It's also, as you go deeper, the pressure in the water gets to be very high. So what you find is that the deeper you go in the ocean, the more specialized the animals are that live there. So the deeper you go, the more they have adaptations that allow them to survive in this environment that's actually pretty harsh. So for the purposes of today, what I'll be talking about, just the shallowest part of the deep sea, which is that starts at 200 meters. This is the mesopelagic, or the twilight zone. It's called the twilight zone because there is still some light that gets down, although for us, if we were to go down there with no lights in a submarine, if we turned out the lights, we wouldn't be able to see anything. But the animals that live there, there is still some light that gets down and they can actually see. So I'll be talking mostly about animals that live somewhere between 200 to 1,000 meters, more or less. So when we talk about the adaptations that animals have that live in the deep sea, what does that mean, and what does it look like for sharks? So on the left, we have a reef species. This is the Caribbean reef shark. It lives in the Caribbean, as the name implies, and it is common around reefs. And you can see from the picture that it's close to the surface of the water. So this is a shallow species. And it's probably, when you think about a shark, this is probably something similar that comes up in your head. That's what a shark looks like. It's just a sharky shark. And on the right, we have a deep sea species. This is a dogfish species, and it lives around 400 meters or 1,200 feet deep, and probably deeper. So the first thing that you might notice, if we were trying to determine, if we had these two next to each other, we wanted to know which is a shallow species and which is a deep species, what would we look at? Well, first of all, the first thing that to me that pops out is that the shark on the right, this guy here, is being held by someone in their hand, so it's small. And you might think that this is a baby shark, but actually this is an adult, and that's just about as big as they get. So there are definitely some deep sea sharks that get to be very, very big, but a general rule is that they tend to be a lot smaller in the deep sea. The second thing that pops out to me that I notice is that they're very small, but the eye is very large. So they have a gigantic green eye with a really dilated pupil. And remember that this is the twilight zone, so there's not much light that gets down there, and they have big eyes with big pupils that allow them to bring in as much light as possible so that they can see in the dark. The reef shark, on the other hand, has a pretty small eye, and it has a pretty small pupil because it's close to the surface. There's a lot of light. It probably actually needs to block out some of the light so it doesn't get blinded. The second thing behind the eye here, it looks like there's kind of a hole in the head of this dogfish shark. And that's called a spiracle. And that allows them to actually pump in water over their gills so that they can extract the oxygen. So there are shallow species that have spiracles. A lot of stingrays have spiracles because they sit on the bottom and they're bringing over oxygen over their gills or water over their gills. But you see this adaptation a lot in deep sea sharks because again, the oxygen levels are low, and so they might need a little bit of extra help getting water over their gills. The reef shark on the left, it swims around with its mouth slightly open, and so the water comes in its mouth and goes over its gills, and that's how it breathes. Something else that's different about the shark on the right-hand side, the small shark, this dogfish, is that it has spines on its fins. It has 2 fins and it has 2 very, very sharp spines. Again, this isn't something that's completely unique to deep sea species, but it is something you see more commonly in deep sea sharks. It's also a kind of a uniform brown color. It's brown all over, whereas the reef shark has counter shading. So its belly is really, really white, and it's darker on the top than it is on the bottom. This helps for it to sort of blend into the background in the blue water. Whereas a lot of the deep sea shark species are kind of just a brown color or even close to black. So when we're talking about what are the differences between adaptations for sharks in the deep versus the shallow, we can look at their eyes, their spines, in some cases their fins, the presence or absence of spiracles, what their gills look like, and the coloration. So why do we study the deep sea? Well, as scientists, we're curious, and deep sea sharks are pretty cool. So we obviously have that curiosity about it. But one of the other reasons that main reasons that we study them is because there are actually quite a lot of human influences on the deep sea. And we want to be able to study what's there in order to protect it or to conserve it and manage it. And what we're seeing, this is pretty common around the world, is that coastal fisheries are declining. In some cases, they've been in decline for quite a while. And this is due to overfishing. And in a lot of cases, it's because of the use of destructive gear like nets, trawls, and other things like that. And because the coastal fisheries, the fisheries that are close to the shore, are getting harder and harder to catch fish, a lot of fishermen are going into deeper waters to catch fish. The problem is that we don't really know what's there in the deep sea. So we need to get a handle on it. And I'm using this as an example. This is a table from a publication called Fisheries of the Future. This is a fishery that is it goes on in around New Zealand in the Pacific, New Zealand and Australia. And there's a fishery for a fish called the orange ruffy. This is a very deep sea species. It lives on seamounts, which are kind of like underwater mountains. And they live on top of them. And the fishermen realized that there were a whole bunch of them that lived on top of these seamounts, and they could send down a net and scoop them up. They originally were called slime heads. That was their common name. But then someone realized that they were delicious. And then they said, well, we can't sell something called slime head for people to eat. So they renamed it orange ruffy. And so it became very popular. This was like the poke bowl of the 90s and 2000s. Orange ruffy was a big deal. So everybody wanted orange ruffy, and fishermen started catching more and more. And in this fishery, they're also catching these other species like the grenadiers, sablefish, dories, and ocean perches. And then as the fishery got bigger, scientists and managers said, hold on a second, we don't know anything about these fish, and we don't know if this fishery is sustainable. So they did some studies, and what they found is that some of these species can live to be over 100 years old. And sometimes they don't mature and they don't reproduce until they're 20 to 40 years old. And that's a problem because they're not able to replace themselves very often. So the fishery can be in really big trouble. The problem is that the scientists and managers realized that these were really old fish that grow very slowly, almost after the fishery was already in decline. So that's why we don't really see a lot of orange ruffy on the menu anymore. But you just said, this is a talk about sharks. So what does this have to do with sharks? Well, here's a picture of the catch of orange ruffy. So the yellow arrow indicates the species that they're going after. This is the orange ruffy fish. You notice that around the orange ruffy, there's a lot of other fish. There's a bunch of different fish species. We probably, a lot of people don't know what they are. I don't know what a lot of those species are. So what happens, as I said, they send down really big nets and they scoop up the orange ruffy. And when they do that, they catch a bunch of other species too. And this is called bycatch. So bycatch are the species that are captured in a fishery that is not part what they intended to catch. And in deep sea fisheries, we know that a lot of the fish are very old, and these fish aren't going to survive, so they can't throw them back in the ocean. And what you might see at the top of the screen here is some sharks that have dark brown uniform coloration, giant green eyes. They probably have spines on their fins, and there's some spiracles I can see there. So we've got some deep sea shark species there as well. The problem is, of course, that we don't really know anything about these species, just like we don't know about the fish. And in some cases, we don't even know what species they are. So in a lot of cases, these fisheries are going forward and they're catching fish and they're catching sharks before we even have any idea anything about their biology or even what they are. So the title of this talk was Deep Sea Sharks in Belize and Honduras. I haven't looked to see where everybody is tuning in from, but I was going to give you just a second. Here's the world map. And if everybody can try to point out where Belize and Honduras are on the map, I'll give you a couple of seconds, see if you get it right. If you pointed in that general direction, you would be correct. So Belize is at the very top of Central America and Honduras is down below that. So here we have Mexico. So Cancun is up at the top, then Cozumel. And if we follow this down, this is called the Mesoamerican Barrier Reef. Mesoamerican Barrier Reef goes from roughly Cozumel down across Belize, around Guatemala into the Bay Islands of Honduras. That's these islands off of Honduras here. The Mesoamerican Barrier Reef is the second longest barrier reef in the world, behind only the Great Barrier Reef, and it's the longest continuous barrier reef in the Northern Hemisphere. So it's a really special region. It has some spectacular reef and some really great fish. And it's just, if you have a chance, whenever everybody's able to travel again, you should definitely try to visit. So traditionally the fisheries, especially in Belize, have been really small scale. So a lot of the fisheries are for lobster and conch, and the fishermen they free dive. And so it's small scale. They're not catching, it's not like the Pacific thing where they're sitting down a trawl and catching hundreds of animals, thousands of animals at one time. The thing is, though, that even small scale fisheries can have very big impacts. And so over time, especially since lobster and conch are delicacies throughout the world, so they're exporting a lot of these, they're actually catching more and more, and the same kind of story that we see in other regions is happening here as well. So each one in this picture, each one of those conch shells represents an ex-conch. And this is just one tiny little site in Belize. So this is happening throughout the region. So the same thing is happening here. We see in other areas, the coastal fisheries are starting to decline. And what do fishers do when that happens? They move into deeper waters. And in a lot of cases, the fish are bigger and they can get very high quality catch that way. And we know from working with fishermen and talking to fishermen in the region that they're also catching sharks as bycatch. And in some cases, they're actually keeping the sharks or targeting the sharks. So that's the what and the why. So how do we study deep sea sharks in this region? When you think about deep sea research, you might think about big fancy research vessels. And this is actually the Alucia. This is a vessel that has been used for a lot of documentaries like Planet Earth. They have a fabulous video on deep sea, actually. I highly recommend the series of Planet Earth. They did a lot of the filming from this big ship. And so they have a helipad, there's a helicopter on there. In the back, you can't see them, but I think they actually have 2 submarines that can go down to the deepest depths of the ocean. You can see they have a room for lots of crew. We work in small tropical countries and we don't have this kind of research budget or access to things like this. So this is not how we study deep sea sharks, unfortunately. We would love to. If anybody would like to donate some ship time to us, we would love it. But instead, this is our research vessel. We use small boats. We have a 25-foot boat that we conduct a lot of our research from. And we work with traditional fishers. So we work a lot on their boats as well. And actually the gear that we use, the way that we catch sharks is designed on the gear that the traditional fishers in the region use to catch fish. And we do it all by hand. So we don't have winches or hydraulics or anything. So we send down what's called a vertical long line. It's hooks that are baited and it sits straight up and down in the water column. It has a buoy at the top and a weight at the bottom and some hooks on the bottom. And we put them down by hand and then we pull them back up by hand. And then you can see on the right picture, the Evaristo on the right-hand side in the red shirt. He's pulling up the very last bit. There's a doohickey there that's a little PVC tube, and that contains a little computer that's called a temperature depth recorder, and it records the pressure and the temperature, so we have an accurate idea of what the temperature and the depth is when we're fishing. And then we don't have any submarines or remote operated vehicles, but we do have a beta remote underwater video, which is a fancy word, or BRUV, for this GoPro, basically, that's in a special housing that we send down, again, by hand, and we also pull up by hand. So it has special canisters for lights, and we'll see some of that in a minute. So I think video does a much better job than pictures of showing what the research is. So this is a brief video that kind of takes you through the whole process. And I'll talk a little bit about some of the video. And there is some sound. So here we are setting the vertical long line. That's putting on the buoy on the top, and that flag in the back is a high flyer, so we can find it again. And we work through all kinds of weather. But you can see a lot of time was spent pulling up lines. This is in Guanaja, here on the neighboring island in Honduras. Here comes our TDR. And you notice that there's a hook with nothing on it, and there's a hook with some bait on it. We spend a lot of time not catching anything, but it is important. And I think it's important to know in science that we spend a lot of time actually looking for the animals that we're trying to capture. So it's not all super exciting, but when it is exciting, it's exciting. So here are some of the animals that we caught. This is Atlantic sixgill shark. If you can see, it only has one dorsal fin. So I mentioned that fins are sometimes a characteristic of deep sea sharks. We use genetics, so we actually take a little piece of the fin, it's called a fin clip, and we store that in ethanol and alcohol so that we can extract DNA from it later. And sometimes that's easier than other times. This is one of the big species, but it's one of the exceptions of the big shark species. And then there's one of the smallest. And there goes our night shark. You can see the yellow tag in the fin. That was a rototag. This is an Atlantic sixgill shark. You can see that tag is much smaller. It's called a spaghetti tag. So we use different tags depending on the size of the shark. This one, they tend to float a lot, the deep sea sharks. So we send a depth release mechanism with some of them to make sure they get back down. Okay, now we're moving into the BRUVS. So this is the bird's eye view. This is what the camera sees when we send it down. It takes usually about 5 minutes for it to reach the bottom, depending on how deep. It can go anywhere from like 5 to 10 minutes to reach. Here's our dogfish. This is the same species. This is that dogfish, the one that was just there, but this is a juvenile, so you can see it's itty bitty. And although it is tiny, it is tenacious. It is really going after that bait cage. We always talk about making videos and putting sound effects over it, like nom, 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 nom. This is in Western Honduras. That's one of the species that's a gulper shark. This is one of my favorite encounters. This is not a shark. I don't know if you noticed, but this is a giant isopod. We did not expect to see it. And they look kind of terrifying until this one sort of like derps into the camera. And then here's our Atlantic sixgill shark. What's great about the BRUVS is it allows us to see the bottom habitat. And it also gives us, in some cases, it gives us a glimpse of the animals in their natural environment. And in a lot of cases, because these are deep sea species and they're not very well known, in a lot of cases, this is the only video that we have of these animals in their environment. So even though we're using small boats and small equipment, we're getting really, really great results. So you saw the video and you saw that we had several different species that we've caught and we've seen on our videos. So how do we identify the species? Because they're deep sea sharks, we don't necessarily recognize them right away because we might not have seen them before. So we use two different techniques. One is taxonomy and the other one is genetics. Taxonomy is basically you measure all of the things. You measure the eye height and the width. You can see the center picture is measuring the snout width. We measure the fins, you measure the tail, you measure everything you can think of to measure, and things that you would never think of to measure, you measure. And you record all of that, and you use what's called a dichotomous key in order to determine the species. We also use genetics. So you saw in the video, we took a little piece of the fin and we put it in ethanol. We send that off to a lab and they extract the genetic information. And there's a database that people upload, other geneticists, they put up their genetic sequences, and you can use that to compare your genetic sequence of your animal to what they have in their database. The problem with both of these methods is that you're using these methods, the measurements and your genetic sequence, you have to compare them to something. And because these are very poorly studied species, a lot of times there's nothing to compare them to. So we end up with a lot of species that we can get down to the family. We know it's a lantern shark, we know it's a gulper shark, but we don't know what the species is because there's not enough information for us to figure that out. Sometimes we also have to take our shark to the vet. And in this case, actually, we took it to the vet and the vet did not have an x-ray. So we had to take it to the human clinic and we got an x-ray. And that was so that we can count all of the vertebrae it has in its spinal column. And that's another way that another form of taxonomy that's used to identify species. And I think Vicky Vasquez is going to be talking on Thursday about how they identify species. So I definitely tune into her talk on Thursday because she knows a lot more about this than I do. And it's going to be a really neat talk. So what have we found with our research? Well, so here's our map again, and we have Belize here on the left, the long one, and Honduras on the bottom. What you might notice, all of these dots represent one individual shark that we caught. And you might notice that all of these dots seem to be really close to shore for the most part, or really close on top of, these are offshore atolls. And that's because here, the blue represents the depth of the ocean, and the darker the blue color, the deeper it goes. So this light color here is like shallow coastal, and as it gets deeper, it goes into more blue. So in a lot of cases, from the barrier reef, it drops off really fast. And so we can be fishing in 1,000 feet of water and catching deep sea sharks, and we're literally you can see land. So almost everywhere that we catch deep sea sharks is inside of land, which is really interesting. It's a great part of the deep sea to be able to research where we don't have to go, thousands of miles away to find these species. Something you might also notice about the list here is that we have smoothhound species 2, gulper shark species 1, species 2, species 3, lantern shark 2 species. So there are 12 species that we've just separate species that we know that we've caught, but we've actually only identified about half of them down to species. So we have some work to do on some of these sharks. And then the stars on these 2 species are new species that have been discovered over the course of our study. One is described by us and colleagues, and another by our colleagues in Florida. So something that you might not know about new species of sharks or anything is that it's not just that necessarily that you go out and you find something you've never seen before. A new species isn't always something that nobody's ever seen before. A lot of times what it is it's a species that we know is there. We might even know a lot about it. We might know something about where it lives and how it reproduces, how it grows and things like that, but we might have just been calling it by the wrong name. So we use our combination of taxonomy and genetics to compare it to the other species in the world to determine if they are in fact distinct species. So in the case of the Atlantic sixgill shark, which is on the left, this is a species we described, I believe, in 2018. Originally, it was thought that the big eye sixgill shark, which is what this was called previously, was distributed worldwide in the Pacific and the Atlantic. And there's one species that encompassed the entire world. We were able to use just genetics to show that actually the sharks that are in the Atlantic Ocean are completely separate species. Even though they look identical, they're a completely different species to that was in the Pacific. So we named it the Atlantic sixgill shark. And then on the right is Genie's dogfish. And you might notice something that these 2 sharks have in common is that they're both adorable because they have those big eyes. Maybe that's just me, but I also have the mirror of it behind me. Genie's dogfish was named after the original woman in shark science, Eugenie Clark. And she wasn't just the first woman in shark science. She was one of the very first shark scientists, and she did produce some seminal work in the field. There's a book about her called The Shark Lady. It's a children's book, and it's really wonderful. So if you have a chance to look for it, it's really great. great resource. So Genie's dogfish was previously thought to be another species as well, and they used a combination of taxonomy and genetics to determine that it was its own separate species. And while we didn't describe it, we were the first ones to provide genetic information of it from a different region of the world. So we were able to confirm just after they described the species that it's also present in Belize. Then we have our unidentified species that we're still working on. We think we have 2 species of lantern sharks, that's on the left. Lantern sharks are cool because they glow in the dark. And again, Vicki will be talking more about lantern sharks, I'm sure, on Thursday. So even though it looks completely black or dark brown to us, at depth and when it swims around, it actually has a pattern of glowing organs on its underside, and it's just a really neat species. And you can see that it's also very, very small. The gulper species on the right-hand side, there are a lot of different gulper species, and this is actually among the most taxonomically confusing group of species of sharks. And so even people who specialize in gulper species have a hard time identifying them because they change a lot from the time that they're young until they mature. So we might have a lot of work cut out for us before we can determine which species of gulper sharks we have. Even that we did compare our genetics to what was available in the big database, and it came up with something that was not feasible. So we're still back to the drawing board. One of our more exciting findings was a tag recapture of a night shark. The night shark, the picture you can see there, it looks a lot more like the shallow water species, like the reef shark. It doesn't have a lot of the adaptations that you see, like the big eye, or spines or anything like that, and it's actually fairly big. The species actually moves quite a lot in the water column, so it spends the daytime at the depth, so probably around 1,000 feet, and at night it comes up to the surface, and so that's when fishermen mostly encounter it, and so that's why they call it the night shark. We have tagged several of this species, and you saw, I think in one of the videos, you saw the big tag in the fin as it swam away. It was actually recaptured by a fisherman in Havana, Cuba. So it was tagged in northern Belize, where the green dot is, and the end of July in 2017. And then 2 months later, it was recaptured in Cuba, and that's more than 1,000 kilometers. So that we don't really know much about the species, and we know next to nothing about them in this region. So that was a really exciting finding. Something else that I'm really excited about, and watching these videos and doing this presentation has made me really miss being out in the field. So I'm excited to get back into this when we can. But we think we might have found a place where some gulper sharks are using an area in Honduras as a nursery. So this red circle and the orange triangles there, squares, triangles, on the bottom, we caught a large amount of 2 species of gulper sharks, like just as many species, just as many sharks as we caught in total. In all of our study, we've caught just that many in that one spot. And they're all juveniles. So it's possible that they're using this area as either a refuge from predators, or it might just be, there might be a lot of food that's there. It's something that we need to investigate. It's also very shallow where we caught them for the species. Gulper sharks tend to be very deep. And they might move up and down at night, but we were catching them more shallow than we expected. So this might be a really special area, and it could be one of those areas that we might think about for conservation, like to set aside. You saw some of the videos from our BRUVS, the Beta Remote Underwater video. I just wanted to show what it actually looks like out on the boat. So we mentioned that I like to brag that we can do deep sea research from any boat. And that includes our camera that we send down. But even that little camera on the little boats that we're on takes up a lot of space. So if we had our camera deployed in its normal fashion, we wouldn't be able to do anything else. We'd have to make special trips just to set the camera. So we actually designed it so you can take off the lights, unscrew it, and it folds down, and it fits nicely in a little bag or a box. And so you can tuck it away when we're doing our actual longline surveys, and then we just pop it out and send it down when we're ready to do our video. And so here are just a few still images from the videos that we've got. So the dusky smoothhound from Lighthouse Reef Atoll. You can also see that there are different bottom types. And so what's one of the other great things about these videos is we can see potential prey items. There's some on the next to that isopod on the bottom that says shrimp. And so you can see how the different habitats might actually influence what you see in the bottom. And the giant isopod, they're funny looking, but it's a really interesting species. They're actually the closest relation is the pillbug or roly-poly. So they're actually more related to woodlice than any other marine species. And of course, we still have lots to learn. We've only identified half of our species, so we have a lot more taxonomy and genetics that we need to do. We have a lot of collaborations with other scientists that are underway, and we're really excited. We think there might be another new species coming soon. We're fingers crossed. We're working on that right now. We also are looking whenever we have animals that we conduct the taxonomy studies on, we also look at their life history. Life history is a study of the age, the growth, and the reproduction of a species. And so that tells us how vulnerable some of these species are to overfishing. And then, of course, we want to expand our knowledge of the distribution and the movement of all these species. We know every time that we set a line down in a new depth or a new area that we see something that we haven't seen before. And we know from working with fishermen and talking to a lot of fishermen that we haven't caught everything that they have. They've seen a lot more things that we've never actually managed to catch or see on video. So we have a lot more to learn. We're definitely going to be expanding our knowledge of the distribution of these animals. And then we also, of course, we have our tag recapture so that we're still putting out tags. It'd be great to be able to put out other types of tags that maybe give us more fine scale movement of some species that we don't know anything about on their movement. With that, I think I will finish. I just wanted to say you can go to our website, MarAlliance.org, and find more information on this. We also do a lot of other, MarAlliance does a lot of research on big fish, other sharks, stingrays, turtles, finfish. We have a lot of information there. And then on social media, we have Facebook, Instagram, and Twitter. So maybe we'll do TikTok soon. Right now, though, the great thing on our social media right now, especially on Instagram and Facebook, is before lockdown happened in Panama, our team in Panama tagged 2 whale sharks with satellite tags. And so they're providing a lot of updates for these 2 animals. And I believe that they need names. So if you go on, you can go and find what these sharks have been doing around Panama. They're moving close to Colombia and Costa Rica, and you can even get in on possibly naming those sharks. So that's all.
Awesome. Thank you so much, Ivy. That was really cool. Yeah, it's so interesting to see research going on in a part of the world where we really don't, there isn't that much work doing and being done, and MarAlliance is really one of the organizations that is doing some of the work in those areas, which is really, really interesting, because a lot of shark research goes on in America, in Canada, in Europe, and there are hubs of activity when it comes to shark science, but we really need to get as much information as possible from all around the world, because there's so much information that we might be missing on when it comes to conservation of species. So thank you so much for that.
Thank you. And I just wanted to add to that, that it's, I think something else that makes us unique, and you said it is really important to get information from other parts of the world, but we're all based in the countries that we study. So we're not, a lot of people come in, you know, they'll come in for 2 weeks and do some research and then they leave. All of our teams are based in the countries where we also work in Cape Verde and West Africa. So we get a lot more in depth, and we work with local communities. So we do outreach and education. So we get a lot of opportunities that you don't get by not being, living in the areas where you're doing research.
Yeah, and that is one of the one of the things that I admire the most, and one of the reasons I love MarAlliance so much, is that you really work with local communities and local fishers, and there's collaboration. And I think that's amazing, because we really need that in today's world, where fishermen have so much knowledge that we're not always tapping into. And so when we actually go and talk to them, we discover things, and we get so much more information than if we were to just come in, do our thing, and then leave again. It's really great that MarAlliance does that. So we have some really great questions coming in, and I'll work my way through them. So you mentioned 2 of the species of sharks that you discovered. well, you as in MarAlliance, and Genie's dogfish is so cute, and we had an author, Heather Lang, a couple of weeks ago, who read her book Swimming with Sharks, which is about Genie, and she met her, and it's sort of like a biographical kid's story, and it's really great. So she also read it to us. So Genie is such an amazing person. She was sadly passed away, but I love that she has, and it's not the only species of sharks that she has named after her as well.
Yes, exactly.
But have you discovered any other species of sharks, and have you yourself named any?
So Genie's dogfish was our colleagues, Toby Daly Engel's lab, and they were the ones that described that species. We were able to contribute to the range of the species, and we also worked with Dr. Daly Engel on the description of the Atlantic sixgill shark. No, I haven't been able to name any sharks. I'm hinting that we're working on the description of a new species. It's the same kind of case though, where it's not like, oh, we've never seen this before. It's something we know is there. It's just possible that we've been calling it the wrong name. So it's possible that I'll get to name a shark, but we haven't confirmed yet that it's actually a different species than it was. But we're still, we're hopeful. A lot of the fishermen that we work with are convinced that we're going to find a mermaid on one of the BRUVS. That's just it.
Yeah, but that's one of the amazing things about working with the deep sea, is that you never know what's going to come out from the dark on the BRUVS and what's going to appear, because there's so much that we're yet to discover down there. So it's really awesome. Yeah. Hannah asked, speaking of deep sea sharks, why do they appear to be, and is it the case that a lot of them appear to be smaller than shallow water sharks?
It is the case. It's a lot of the deep sea species, and I think that the smallest shark species is the pygmy lantern shark, which is a deep sea species.
Yeah, there's debate, the ninja lantern shark or the pocket shark as well.
Pocket, the pocket, yeah. So it's more, a lot of the deep sea species tend to be small. A lot of the gulper sharks, they're sort of like a meter or less than 3 feet long. So there are these cases where they have gigantism. So the giant isopod is a case of something being big where it really shouldn't be, where most things are small. So things tend to be smaller because there are fewer resources in the deep sea. There's less food, there's less oxygen. So it makes more sense to be more compact because there's just less to eat and less to breathe. But then you have the Bluntnose sixgill shark and some of the sleeper sharks and Greenland sharks and things like that that are very, very big. But the ones that tend to be very big have very slow metabolisms. They call them sleeper sharks for a reason. They move pretty slowly. They don't see very well, a lot of them. And so they have a totally different way of dealing with the depth than the smaller shark species do. So the smaller ones are probably a little bit more active. But yes, it is kind of a general rule that deep sea animals overall tend to be smaller.
Cool. And then we get a lot of questions about the methods that we use. And in this case in particular, some people are asking if anything, when you take the sharks out of the deep sea, does it affect them at all? Sharks don't have a swim bladder, so the pressure doesn't necessarily affect them the same way than if we were bringing other fish up to the surface. But does it have an effect on them?
Absolutely. So these, as I mentioned, it's very cold in the deep sea as well. So a lot of the places where we have the little temperature devices so we can measure it. So the bottom temperature ranges anywhere from like 13 degrees Celsius down to about 6. So that's like 50 degrees down into the 40s. So it's cold. And when we live in the tropics and we're pulling them up to the surface, and the surface water is sort of in the 80s. So it's a huge difference in temperature and light and in pressure that they undergo in a very short period of time. Some species are better at dealing with it than others. We have found that actually the gulper sharks are, and there have been other studies that have shown that they just really don't cope very well with the change. And I think a lot of it has to do with the temperature. I think the temperature really stresses them out. So we actually stopped going to areas where the gulper sharks were, and we stopped targeting them because of that. So we send cameras down instead. Other species like the sixgills, you saw we had a lot of videos of them swimming back down. And so I think because we're not putting out a lot of some other deep sea research, they put down lines to catch sharks and they soak them for hours, sometimes overnight. And then they bring them to the surface, and it takes them a long time to get to the surface. And then they might be on the surface for a while, and then they release them. We only soak our lines for 30 minutes to an hour. They get up to the surface very quickly. We tag them, we measure them, and we send them straight back down. So I think the faster that we can work them up, the faster we can get them. And you saw we actually have a little device so we can weight them and send them down really quickly as well. So we're learning ways to help get them back down. But yes, they definitely are. It's like you mentioned with fish, they actually have an air sac that helps them maintain where they sit in the water column. So like when you hold your breath, you go up higher. When they come up, just like a scuba diver, they undergo the bends, and it's usually fatal, especially coming from those depths. Sharks don't have that, but it doesn't mean that they don't undergo some stresses from going under those rapid changes. And they are adapted for deep sea. They're not meant to be in the shallows. So yeah, we do everything that we can to get them back down as soon as we can.
Yeah, and that's something that we talked about it a little bit yesterday with Gillian, who was discussing methods that scientists use to study sharks. And whatever we do, we always try as much as possible to reduce the impact that we have on these animals. So we're always looking for new ways to improve our methods and to reduce that impact. And so in as you just said, it might be using cameras instead, or fishing. I don't know if fishing at night reduce that impact?
It might, because of the light levels. It might not be such a big shock to the system. We have done that. Sharks, especially deep sea sharks, they move up and down at night. So a lot of sharks that are deeper come up shallower. So we catch different species in depths. We catch gulper sharks much shallower at night. We also, the big Bluntnose sixgill shark that we caught fairly shallow at night. So that also could reduce. We also found that the time of year, the temperature doesn't change a huge amount here because we're getting closer to the equator, but in the wet months and the winter months, the water temperature is a bit cooler. So we find that the temperature difference is not so great. So we can also work in the winter months to try to help reduce some of that.
Very good. And we have a question about, so you talked about how you you bring them all up by hand. So you pull and does that make it really hard when it's very heavy sharks like the sixgill sharks? How do you deal with that?
It does. So what's interesting is that even though you have more than 1,000 feet of line that you're pulling, you can normally tell when there's a shark on, even some of the small ones. And when we caught the big sixgill shark, I think it actually helps us that we are pulling it by hand. And I had a very experienced fisherman who took over that. And he allowed it, the line it kind of stretches and bends. And so because he was pulling it up by hand, he could feel when the shark was running. And so he could let it go. And this was actually a tiny, tiny hook. That was a very small hook that we caught that giant shark on. And so, yeah, you can definitely feel it, but you can also help the shark out by like letting it, if it's swimming away, you can let the line go out a little bit. If you can, and you can also pull it up more quickly. So it's not as big of a difference pulling up the line with something on it as it is, you would think, because they also are swimming and they're not necessarily always trying to pull back down.
Cool. And then the other methods that we have people wondering about is in some of our previous webinars, people have spoken to us about working with local fishermen communities to get sharks from bycatch. So when fishermen go out and catch put their nets out, sometimes they pull up species that they didn't target and they give them to scientists. Is that something that you do with communities in where you are in Honduras as well?
So the interesting thing about Honduras, I didn't mention, is that Honduras is a shark sanctuary. So it's actually illegal to land sharks. So we can't collect sharks that way from fishermen. In Belize, we do a little bit of that. For the most part, they don't really target sharks. There is a time of year when sharks are targeted a little bit more, and we are seeing more and more the deep sea sharks kind of showing up in the shark landings. But yeah, occasionally I have contacts that will call or Facebook or send a message whenever they catch something weird. And most of the time they release it, so we don't get it. And there's not like big trawl fisheries and things like that here. So they're not bringing these things to shore and then picking through the catches. It tends to be on a hook and line, and most of the time these guys we're going to release the sharks. So they'll send us a picture if they take one, or they'll give us a location. But yeah, it's great to have those contacts. And here as well, that even though it's illegal in Honduras, it's illegal to keep sharks. They do catch them, and so they can tell us where they are, and they send locations and sometimes pictures.
Awesome. All right, and then we have questions about how do you think, Rachel asks, how do you think climate change will affect deep sea sharks?
Climate change and deep sea sharks. I think it probably has more to do with how the climate change is affecting the fisheries and the communities, because I think that the actual physical effects in the deep sea will be delayed. We probably won't see them quite as soon as we're seeing now. A lot of the communities that we work with are already being impacted by climate change. This rising sea levels, fishing grounds, the weather has changed. You can't rely on the same weather patterns that you used to for fishing. So I think that is the effects of climate change might actually be more fishing in deep sea because coastal fisheries are changing so much.
Uh-huh. All right. There's some really awesome questions. I'm trying to pick which ones, but there's loads. Really great questions. A very simple one. What's the biggest deep sea shark that you've caught?
That was the Bluntnose sixgill shark. That was definitely the biggest that we've gotten to the surface. It's possible that some may have gotten off. It was about 12 feet long or 4 meters. And we caught it on the small hook, and we were able to, when we bring them up to the boat, we put a tail rope so that we can keep their head and their tail, kind of keep their body straight. And it broke the hook off as it got to the surface. So we still had it on the line, but because we didn't have the head, it kind of was swinging around. So we took a fin clip and let it go. We weren't able to get a tag on it. But that was exciting. And it was kind of at the time, the fisherman that we were working with, Rachel's been working with him for years and years, and that was like one of his big lifelong goals was to catch the Bluntnose sixgill shark. So it was really exciting to be able to get that one, and that was obviously it was on my bucket list as well. So it was really awesome.
Great. Do you find that what are your interactions with the fishermen? Because they come out with you. Are they really interested in what you do? Are they really happy when they catch these sharks and to see them swim off again? What are their reactions to all of your research?
So that's interesting. We have teams that we work with every year that do the normal monitoring that we do, the shallow monitoring. So we have places that we go to every single year when there's not a pandemic. For instance, Lighthouse Reef in Belize, we try to go to, there's several places in Panama and Cape Verde. And so we have, in those places, we have teams that we work with over time. And the ones that come back again and again, obviously, are the ones that are more interested in the research. They like to see it. They're curious. And we've had shark fishermen come and work with us who said that if they could do it full time, they would not fish for sharks. They wouldn't kill sharks. They would tag them and release them. For the most part, the fishermen that we work with are super curious. They teach us a ton. Like we learn probably as much from them as they learn from doing surveys with us. So there's a great information exchange. Rachel likes to say that fishermen are PhDs of the sea. So we get tons of information, and there's just a great trade-off. And we exchange fishermen among countries so that they can see how different areas and the way resources are managed, how that affects the things that they are interested in, which is fishing. So yeah, the fishermen that we work with, especially the ones that we work with on a regular basis, it's, sometimes it's the highlight. It's a highlight of their, their time and their year, and they often ask to come back again and again.
Awesome. And I'll just ask a couple more questions and then we'll end it there. How is there ever any diving involved in the work that you do?
Specifically, the work that I do with deep sea sharks, no. There's a lot. We have, unless we were to do some of the filming, we have throw people in the water with a mask and snorkel to take photos and videos and things like that, but it's not necessarily diving. Right now, well, for instance, in Panama, tagging whale sharks and manta rays and things like that, sometimes that's done with scuba diving. So a lot of times it's free diving though, as well. So it's not necessarily a big part of our work. I personally have never scuba dived for work. As part of my research. But there's also spawning aggregation work is for diving as a requirement. And that's something that we've done in the past and would like to do, again in the future. So it's, for me personally, no, but our group and our program, yes, diving can be definitely an important part.
And I guess anyway, right now, everyone is at home doing data analysis and writing, right?
Yeah, exactly.
Okay, and I said I'd finish with this one, but I'll ask you two more questions. One is, the work that you do specifically is in the aim of conservation in the end, right? Mm-hmm. So how do you go about, and this is a question that Rachel has asked as well, is what's the best approach to, but I think it's really interesting to ask this for everyone watching, is what's the best way to protect deep sea sharks? How do we protect, especially when the limit between shallow water and deep water is so close, like in Honduras?
Right. The best way is not, there's not one good answer for that. A lot of it will depend on which country you're in, which region you're in, and who it is that is interacting with those resources. So in a lot of cases in small countries, and especially in small tropical countries, the governments just don't have the capacity to enforce regulations. So you could put in a protected area, but if nobody's around to monitor the protected area, then it's not really a protected area. Same thing with closed seasons. So honestly, in a lot of cases, the best way is by working with communities and giving communities the information that they need to make decisions to not fish during certain times of the year. So just to say, maybe at this time that you can do a voluntary closed area to make sure that next year the fish are able to reproduce. In other areas, it might be that you have very strong support from managers and you have the protections in place and you have patrolling and things like that. And in that case, setting up a marine park or some kind of a closed area might be the best solution because you have the enforcement, but you also don't want to negatively affect livelihood. So there's a lot of sociology and other research. You need to know your communities, and it's you can't just come in and make one big statement and expect that's going to work for all areas.
Yeah, there's no one size fits all when it comes to conservation. And I think, again, that's one of the amazing things that MarAlliance has done is you really have to understand the communities and why they're fishing sharks, not just where or when, but also the why behind it, understanding, is it their main source of livelihood, or are they fishing them just for the fins? Are they fishing it for the meat? And what are the reasons behind that? And then really working with those communities to find alternative solutions, which isn't always easy. And people think that banning shark finning everywhere will just be the solution, but it can't always be like that. So it's really important to work with those communities and not against them.
Right. Well, and exactly. And for instance, here, finning isn't really the biggest problem. You also have to consider cultural considerations. A lot of shark consumption and fish consumption has to do with the Easter season, the Lenten season, when they're not eating red meat. So there's a lot of fish consumption, and sharks get mixed into that. And a lot of people don't realize they're even eating sharks. They consume it as a dried fish, and so they think they're eating dried fish. So there's another aspect on top of that, is education of communities, interaction with communities, to make sure that they understand what they're eating, and that shark's really not that good for you anyway. When you eat it, it's actually pretty bad for you. It's high in mercury, and if people have that information, then they can make those changes themselves, and then that sort of makes its way up to governments.
Yeah. Awesome. Okay, I'll finish it there. Thank you so much, Ivy, and thank you everyone to watching for your also awesome questions. There's been some really great ones. If I didn't get around to yours, I'm really sorry. We're just tight on time. But Ivy, can you point us to any social media direction that we can follow to
Absolutely
get our answers?
We're actually right in the middle of a campaign to answer questions. So tell us what you wanted to know is the campaign that's happening on Instagram, Twitter, and Facebook. You can go on any of those. It's at MarAlliance, all one word, MarAlliance. And I mentioned before that you can follow our whale sharks and maybe even help name them. We have 2 whale sharks that need names that are off Panama right now. You can go and look at these cool maps that we've got of where they're moving around. But yeah, we're pretty active on all of our social media right now, and especially now, we're trying to find new ways to communicate and get information out. And so definitely reach out to us, ask your questions.
Awesome, thank you so much. And I believe that at least the link to Twitter, to your Twitter, is on our website at sharksforkids.com/webinars, and then you'll find Ivy's talk from today, and underneath it will be a link to the Twitter, to her Twitter. For any other questions about sharks in general, again, as I said before, feel free to head over to our website, sharksforkids.com. There's loads on there. You've heard me say it before, so I won't repeat it. But follow us on our social media, on our website, and join us again for the rest of this week for some awesome women in shark science. Thank you so much, Ivy. Have a lovely day.
Thank you.
And we'll see you soon.
Okay.